Hello, good morning, my dear students. So today again we are meeting in another class. Today we will be doing effects of heat on matter, page number 5050. Yes, so last class we had done differences between solid, liquid and gases in terms of shape and volume, arrangement of molecules, intermolecular force of attraction, intermolecular space, kinetic energy, compressibility, storage, examples, etc. And then Brownian motions. Clear? That was done in the previous classes. So today we will do from page number 50, effects of heat on matter. So when heat is provided to any form of matter, many changes occur. That means when heat is applied or when heat is provided in any form of water, either in solid or in liquid or in gas, clear? So there will be some changes. Clear? So the effects of heat on matter are, there are three changes especially, that is expansion, clear, then change of state, and then chemical change. So these are the effects of heat on matter, clear. So let us see about expansion. So matter expands on heating and contracts on cooling in all the states. So remember, matter expands on heating and contracts on cooling in all three forms of matter, clear, in three forms of states. On heating, the particles of matter start moving rapidly. Remember, when we heat matter, the particles of molecules or the particles of the matter, clear, they start, what you call it, moving rapidly, clear, and start pushing each other, clear, they start pushing each other. So due to this phenomenon, what happens? The intermolecular space between them increases, clear. So due to this phenomenon, the intermolecular spaces between the molecules, clear, increases, and as a result, the size of the substances also increases. The size of the substance, clear, that also will increase. So this increase in size of the matter is called expansion. That is known as expansion. Clear? On expansion, the basic properties of matter such as volume and shape also get affected. Clear? So on expansion, when the matter expands on heating, the basic properties of matter such as volume and shape also get affected. Clear? So liquids expand more than solids. Remember, liquid expands more than solids. Solids are compact. So that means that they cannot expand as much as liquid. Clear? Liquid expands more than solids because of lesser intermolecular force of attraction. I have already told you, clear, the molecules are packed in solid so that the expansion is less. Whereas in liquids, the intermolecular force of attraction, clear, is less, clear, so that the expansion is more. Gases expand the most on heating because of extremely weak intermolecular force of attraction. Now just see, clear, in gases, the, what you call it, the expansion is more than solid and liquid because it has got a weak intermolecular force of attraction. Clear? It has got less intermolecular force of attraction. So this is the effects of heat on matter on expansion of solid. Clear? Now there is an example, the experiment. The experiment is to demonstrate thermal expansion in solid. Clear? What are the things required? It is given here. Bunsen burner 1, clear. and then a beaker containing cold water, clear, a metal ball, a small metal ball, and ring apparatus, clear, and then a ring apparatus. Now method how to do it. First set up the ball and ring apparatus, clear. First you set up the ball, clear, in the table, on the table. You just set up the ball and the apparatus. Then ensure that the metal ball can easily go through the ring attached to the stand at room temperature. Just you should know that the metal ball should get inside into the ring. Clear? The metal ball should get inside the ball. Then turn on the Bunsen burner. Then heat. Clear? Heat the metal ball and heat the metal ball over and heat the ball over it for a few minutes. Clear? Then try to pass the heated ball through the ring. So after heating, you again try to pass the metal ball inside the ring. What will happen then after heating? Now put the heated ball in the beaker containing cold water and again try to pass the ball through the ring. First of all, after what will happen? After heating, what happens? The metal ball expands and it does not pass through the ring. Clear? Then you can again what you can do it is put the heated ball in the beaker containing cold water. Again put it in the cold water, the heated ball, clear, through the ring as it has expanded. That means it was expanded, clear, when it was heated. So what is the observation? Post heating, the ball does not pass through the ring as it has expanded. So post heating, the ball does not pass. Clear? After heating, the ball does not pass through the ring, but after cooling it again, the ball will pass through the ring. So once the ball is cooled, it contracts and passes through the ring. So after cooling, what happens? The ball contracts, clear, and then it passes through the ring. So what is the conclusion then? So we can conclude that solid expands on heating and contracts on cooling. Clear? So solid expands on heating and contracts on cooling. So this is the very simplest experiment proving the expansion in solids. Clear? There is another experiment, activity 3.5, to demonstrate thermal expansion in solids. A round bottom flask, clear, then a capillary tube, single hole rubber cork, tripod stand, water, wire gauze and Bunsen burner. It is in page number 51 experiment. So how to do it? Look at there. Fill the round bottom flask with water up to its brim, clear, up to its brim, that means up to the top level. Close the mouth by using a single hole rubber cork. Then you close it, clear, with a single hole rubber cork. Then now insert the capillary tube into the flask through the rubber cork. Insert a capillary tube inside the cork, clear, in such a manner that some water from the flask gets into the capillary tube. So in such a manner, right, when you are pushing the capillary tube into the cork, that means the flask gets into the that some water from the flask gets into the capillary tube. Then label the water in the capillary tube, how much it is, clear. You just label the water, how much it is in the capillary tube, and then keep the flask over the tripod stand and write and wire gauze, clear. Keep the flask over the tripod stand and wire gauze and heat the water with the help of burner. Clear? You just put it over the tripod stand and then heat in the Bunsen burner. Note the water level in the capillary tube. Then again you note down the level of the water. So stop heating the water and let it cool down. Stop heating and then again you just let it to cool down for some minute or for some time. Clear? So then again the water level in the capillary tube. Note the water level again. Clear? In the capillary tube. Then what do you observe? The water in the capillary tube rose when the water was heated. The level of the water will rise. Clear? The level of the water will rise and came down when heat was removed and up and water cooled down. So again after some time when it is cooled, clear, the level of the water also comes down. Clear? So this proves that to thermal expansion in solids. Clear? And the conclusion is same: liquid expansion heating and contraction cooling. So this is the another experiment proving the thermal expansion in liquids. Clear? So that means we have done both. Clear? Thermal expansion in solid also and the thermal expansion in liquid also. Clear? Proving proving that the water expands on heating and then or the matter expands on heating and then contracts on cooling. So these are the two experiments. Clear? So we will do this much for today. So again we will continue in the next class. Rest. Okay. Thank you.